In this lecture, we will discuss bilateral arm-leg lead reversal and how to identify it on the EKG. Making sure that the EKG leads are connected to the correct electrode position is important for getting accurate rhythm strips as well as 12-lead EKGs. If the leads are reversed, we call this lead reversal, and it can often produce EKG abnormalities. It's important to be aware of these accidental misplacements of the limb lead electrodes because they can mimic various pathology, including chamber enlargement, an ectopic atrial rhythm, or even myocardial ischemia and infarction. Now, when the limb electrodes, that is the left arm, the right arm, and the left leg are exchanged without disturbing that neutral or right leg electrode, then Einthoven's triangle is flipped 180 degrees, okay, or it's rotated, and that results in switching of positions of these leads, of them becoming inverted or remaining unchanged. It really depends on the initial position in the vector. Now, in this case, we're disturbing both leg and arm leads, and because of this we will be disturbing that neutral electrode. Okay, so remember, the goal here is to be able to see why these EKG changes occur, then be able to reason them out on your own instead of memorizing anything. We'll also mention a few things here to help identify this sort of lead reversal. Here we'll be looking at what happens when there is bilateral arm-leg electrode reversal. This means that the electrodes on each arm are switched with their corresponding leg electrode. So the left arm and the left leg electrodes are reversed, and the right arm and right leg electrodes are reversed. In this case, Einthoven's triangle collapses to a very thin slice, with the left leg electrode being at the apex. Okay. So again, when we talk about this arm and leg reversal, okay, so we have a reversal of the arm and leg on each side. So that means the left and the right. So the left arm and left leg are being switched. So here's our left arm, and this is our left leg, and you're having these two being switched so that now our left leg is up here and our left arm is here. And we're also doing the same with our right arm and the right leg or neutral electrode. Okay, so those are being switched as well. So now the right arm will come to the right leg or neutral electrode's position, and the right leg will come to the right arm's position. So now the right leg or neutral electrode's here, the right arm comes down here in this position. Okay, so hopefully that makes sense so far. Now, what we said here is that the left leg will be at the apex of this thin slice. Okay, so we have the left leg now sitting up here at the apex of this triangle. Now, both the right arm and the left arm electrodes are adjacent at the feet and record nearly identical voltages. Therefore, the difference between them is negligible, and lead 1 will be a flat line with zero potential. Okay, so remember that lead 1 is from the right arm to the left arm. So this is lead 1, okay, heading in this direction. And what we see here is also when we switch them, the right arm is here, the left arm is here, and they're pretty much heading in this direction. It's going to be pretty much zero potential, okay, as it sits there, as they're pretty much identical, okay. So this will be zero potential. Here's lead 1, and it will be 0. So here's normal lead 1, okay, and this is what happens when we have this bilateral arm-leg reversal. Here's lead 1. Notice that it becomes a 0 potential. Okay, that's something to remember because it will distinguish it from other sorts of lead reversals. Okay, so lead 1 is a 0 potential, or that flat line. Now, additionally, the inferior leads 2, 3, and AVF will become identical and equivalent to an inverted lead 3, and this is because they are all now essentially measuring the voltage difference between the left leg and the arms. Okay. So let's think about this, okay? So normally imagine like our heart sitting at the center, and now we're switching these, so our heart's still here, okay? But notice that lead 3 is here, normally going in this direction from the left arm to the left leg, okay? And because it's switched, now lead 3 is going in the opposite direction, okay? So again, here's our left arm and our left leg, and it's going in this direction, okay? And remember, the lead 3 is over here on this side of the heart, okay, or measuring in that direction. So you can think of it, now lead 2 also came over on that side, okay? So now lead 2 is here, which remember, lead 2 is from our right arm to our left leg, heading in this direction. So again, we're going from our right arm to our left leg, and it'll be going in this direction. And because it's pretty much on the same side as lead 3, it's going to be an inversion of lead 3, okay? And again, we also have lead AVF, which is down here at our left leg, our AVF will be heading in this direction. So you pretty much have our inferior leads, 2, 3, and AVF going in the same direction. And that's why we say those inferior leads are pretty much identical, representing an inversion of lead 3. So here are our inferior leads. Okay, and you can see them all representing an inverted lead 3, so pretty much this being inverted. Okay, so we can see that here these are all inverted lead 3s, and these are our inferior leads pretty much being the same. So again, lead 1 is 0 potential, or a flat line, and we have our inferior leads are becoming inverted replications of lead 3. Okay, so hopefully that's making sense so far. Now, the displacement of the right leg or neutral electrode makes leads AVR and AVL mathematically equal. Therefore, they will appear identical, but different from the baseline EKG. Okay, so now we're looking at leads AVR and AVL. Okay, so AVR, let's just erase some of this down here. You can see AVR is here, AVL is here. Okay, and you can see that this is where our right arm and left arm is. Okay, so remember, here's our left arm that has AVL. Now it's down in this position. And we said the right arm with AVR here is now down here. Because they're essentially now at the same level, they will be pretty much identical. Okay, so if you look, here's AVR and AVL, and they're pretty much become equal. Okay, so AVR and AVL, these are pretty much the same. Okay, and you can see how you can space those out. Lead 1 being the 0 potential, 2, 3, and AVF, inversions of lead 3. Okay, so these are all inverted lead 3, and then AVR and AVL pretty much being identical, but different from the original EKG. Okay, so you can see that they're both different here, but they're identical to each other after this bilateral arm leg lead reversal. Now, one final thing to be aware of is that the precordial voltages may be distorted. And remember, this is because we're moving the right leg or neutral electrode. Okay, so whenever you move that right leg or neutral electrode, it can distort those precordial voltages, which is lead V1 through V6, that aren't shown here. Okay, so let's review what we discussed before we end. So bilateral arm leg reversal, remember what we have going on is the left arm and the left leg are switching places. Okay, so those here, all right, and we have the same thing happening on the right side, the right arm and the right leg switching places. And because of this, the Einthoven's triangle, which we see here in the original one, will now collapse with the left leg at the apex. And remember, lead 3 becomes inverted, okay? And then when we look at the inferior leads, 2, 3, and AVF, they all become that inverted lead 3, okay? And we saw that here. And then we mentioned that lead 1 becomes a 0 potential or a flat line. That's one thing to identify this sort of lead reversal. And remember, the ones that are identical, certainly we said 2, 3, and AVF, but also AVR and AVL. Okay, so these ones here are identical, but remember they're different from the baseline EKG. And lastly, don't forget that moving that right leg or neutral electrode can also distort precordial lead voltages. Well, that's the end of this lecture. We discussed bilateral arm leg lead reversal and how to identify it on the EKG. I hope you learned something.